Okay guys, we're going to start. This is section 5.3, logarithmic functions. So the first question says to find the inverse. Well, we know how to do that. All we have to do is switch our x and our y. Okay? So now I switched it, but what do? My next step is that I'm supposed to be able to solve for y. It's kind of difficult to solve for y since it's the exponent. So the only way we can do this is by using a log. Y in this case is equal to the logarithm base b of x. And that's how we would solve this inverse. So as you can see, the inverse of an exponential is a log, and vice versa. The inverse of a log is an exponential. And so that's what this next part talks about, is just the definition there of log. So we define the expression log base b. We say that's called base b because it's the lower number down. It's like its base. Of x means the power to which b must be raised to yield x. So a log is just an exponent. It's the power, it's the exponent. Log base b of x is read log base b of x, or the logarithm of x to the base b. Usually I'll just say log base b of x. You can switch back and forth from exponential form to logarithmic form. So y equals log base b of x is the same thing as saying x is equal to b to the y power. So the y comes around and becomes your exponent, the b is now your base, and the x is what we call the argument. So I'll write those here. X is the argument, b is the base, and y is the exponent, or the power. So now when we want to fill out this chart, flipping back and forth between exponential form and logarithmic form. And so 4 to the third, if I want to rewrite that, 4 to the third equals 64. Rewrite that in log form. I just write log. The base of the exponent is that number 4. That comes down into a subscript. The argument is now the 64. So those are basically switching sides. And then the exponent comes to this side, and that is equal to 3. So we have log base 4 of 64 equals 3. For the next one, let's go back the other way. So that base that's there is going to come up and become the base of our exponent. The number by itself on the other side is my exponent. And then the 1, which was my argument, is now what that's equal to. And as you can see, that is a true statement. 5 to the 0 equals 1. Same thing with this one. This would be log. Bring down the b as your base. Switch the other two. So a is here now, and the exponent is by itself on the other side. This next one, I have base x raised to the z power, and that is now equal to the argument of y. For this next one, we would say it's the log base e, since that's the bottom, and then switch the x and the y, so this would be of y as my argument equals x. We're going to talk about this guy. We don't write log base e. We actually do a shorthand for that. Since it recurs so frequently that we have a base e, we actually change it to an L and an N, and that's called natural log. I'm going to show you that down here at the bottom of the page in a second. But this would be the natural log of y equals x, and then there's actually no base anymore. Whenever we see LN, again stands for natural log, that represents automatically a base of e. So for this one that had the natural log there, again, that's assumed that I have a base of e in there, even though I can't see it. I rewrite it as e to the b power is equal to that argument of a. All right, question 4 says to find each of the following. Well, let's figure this out. So this is asking me 2 to what power, right? The log is equal to the power always. So what's the power, or the exponent, that'll give me an answer of 4? Well, it's obviously 2, because 2 to the second power would equal 4. Okay, 3 to what power is going to give me an answer of 1? Well, 3, sorry, could you see that? 3 to what power gives me an answer of 1? Well, obviously 3 to the 0 power is equal to 1. So log base 3 of 1 is equal to 0. 4 to what power is equal to 64? That's what I'm asking here. So obviously it would be 3, because 4 to the third power is equal to 64. For the next one, it's 5 to what power equals square root of 5? Well, obviously that would be 1/2 because 5 to the 1/2 is the same thing as taking the square root. For the next one, 6 to what power is going to equal 1/6? So I'll figure that one out. Should be -1, right? 6 to the -1 power gives me 1/6. How about for this one? 7 to what power equals 1/49? Well, 1/49 is just like 7 squared, so that would be to the -2 power. And so that log would be equal to -2. Your calculator will do all of these logs as well. You need to go into log base if you have the new operating system, and then you can type in any base that you want. Now, most easy problems like this I would put on a non-calculator part, but if you needed to, log base is just under the math menu. So if I go to the math menu, arrow over to number, and then actually, wait, that's not where it is. Stay there, sorry. Stay back in the math menu. It's actually quicker if you go up once you're here. So once I'm in the math menu, instead of going all the way down, because it's almost all the way at the bottom, it's quicker to just go up, and it's option A there, called log base. I hope you can see this okay. I hit enter, and then it gives me options just to fill that in. So this last one was log base 7 of 1/49, and you can obviously check your work there, and it gives you -2. Okay, and I can show you that again in class later. Okay, for these ones as well, you could obviously use your calculator. There is a button for log and a button for natural log. There are 2 important definitions you need to know. The first one is the one I mentioned earlier, called log base e of x, which is ln of x. This is what we call the natural logarithm, so natural log. This other one, log base 10, it occurs very frequently, and so we call it the common log. And it occurs so frequently that we get lazy and we don't want to write the 10 there, so we just write log of x. So if there is no base whatsoever, you should assume it is 10. If it's an ln, you assume it's a log with a base of e. Okay, so memorize those 2. So what would natural log of e be? Well, again, I'm assuming that's a base of e, so I'm asking myself, e to what exponent equals e? The answer is going to be 1. Okay. How about for this one? A base of e, so e to what exponent equals 1? Answer is obviously 0. How about this one? E to what power equals this whole thing, e squared? Well, that's kind of tricky, but the answer is just 2, right? Because e squared would equal e squared. How about this one? Again, it's like a base e. E to what power equals the square root of e? Well, that's obviously 1/2, since that's the same thing as taking a square root. All right, let's try these on the next row. These are all common logs. So notice there's no bases on any of those. So if there is no base, you assume it's a base 10. Okay, so again, for common law, I'm assuming a base 10. So 10 to what power gives me 100? Well, that's obviously just a 2. 10 to what power gives me 0.001? Obviously -4. Sorry, I had to think for a second. Right, 1, 2, 3, 4. 10 to what power is going to give me the square root of 1,000? Well, let's figure this one out. Let's rewrite this. 1,000 is the same thing as saying 10 to what power? Third power, correct? Because there's 3 zeros. And then it's the square root of that. Well, the square root is the same thing as having a rational exponent of 1/2. So I could just rewrite this entire expression as 10 to the 3/2, and so my answer would just be 3/2. How about this one? 10 to what power would give me 10 times the cube root of 10? Well, again, let's rewrite that. That's like 10 to the 1st times 10 to the 1/3. And if I combine those two together, when you multiply, you add. So 1 plus 1/3 just gives me 4/3. And my exponent would be 4/3. Again, if this were in a calculator part, you could obviously just type that into your calculator. The log button on the left, on the lower left, this button right here, assumes base 10. That's your common log button. This one right here is the natural log button, so that assumes base e. And so you could just type those in if this were a calculator part. which quantity is larger is our next question here. I'm going to, well, we'll do these last two. So which quantity is larger? Well, I would just work both of those out. And so this one is asking me 3 to what power gives me 10, and this one's asking me 7 to what power gives me 40, right? That's really what I'm asking here. And I can actually, instead of those question marks, I'm going to go ahead and give those variables. So let's call this one x, and we'll call this one y. And so I don't exactly know 3 to what power gives me 10. It's going to be a decimal. But what does that decimal have to be between, right? It's going to have to be between a 2 and a 3. Do you agree? Because 3 squared would give me 9, and 3 to the third would give me 27. So between 9 and 27 is where the 10 is going to fall. How about this one? What does y have to be between? Well, 7 to the first is 7, and 7 to the second is 49. So 40 is somewhere between 7 and 49. So which of these two quantities is larger? Well, it's going to have to be that first one, since this is larger. This interval is larger than the other interval. Okay. For this next one, how about log base 4 of 32? Well, I would say 4 raised to what power? And again, I can just use an x here instead of those question marks I was using. So 4 raised to the x equals 32. Well, there is no number that gives me 4 to the 32. But what I can do is what we were doing yesterday, which was rewrite this as 2 squared to the x power, which just gives me 2 to the 2x. And then 32 can be rewritten as 2 to the 5th power. And so now, since they both have the same bases, those bases basically disappear, and I set my exponents equal to one another, and my answer is x equals 5/2. And that's part 1. I will stop there, and then we'll go on to the next video for part 2.